Good morning, everyone. It's already 11:02. Okay, good everyone. My name is Ifeoluche, and I'm the lead for DSC in Lag. So this is a collaborative cloud session by DSC Unilag and DSC Bayero Kano. So in this session, we'll be having both Bakari Emmanuel and Abba Jibril speak to us about the cloud. First off, we'll be starting with Bakari Emmanuel talking about Docker. Okay, over to you, Bakari.
Okay, thank you, Fiona. So hello everyone. I'll be taking you through just like a short intro on Docker. Nothing too exciting, just like a very brief intro as to like the internals of it and like how it works. Would it be preferable if I share my screen? Yeah.
Yeah.
Okay. So share my screen now and present. Okay. Is that fine? Yeah.
Yeah, I can see it.
Okay, cool. Let me make a change here. Okay, good morning, everyone. My name is Emmanuel Bakare. I'm currently a contract worker at Replex and also double down at the Amos Cloud. I'm a DevOps and Linux fanboy. People call me Backman indirectly because Bakare and Emmanuel have back and man in it, so it's kind of like a mixed weird term. And I'm also, a DevOps guy, so pretty much these things come naturally. So today I'll just be like walking through just a short intro on what Docker is, what it's actually built out of, and how it works generally. Before Docker, the way software was mostly managed was if you wanted to run software, you needed a VM. And not just a VM, you needed an environment that would run it exactly how it's seen. Yeah. You would basically take everything you have there, carry it to another server, maybe over FTP or some other medium, and then run it there. But the problem with that was every single time that VM changed, or every single time that someone did something on their system that they couldn't replicate on the server, you had long debugging hours and tons of time to fix things. So the way Docker came into the ecosystem was a way that you could now pre-package software in such a way that all the configuration, even right down to the environment variable, can basically be in a somewhat zipped environment like that you could now carry around without expecting it to fail. Mostly due to the fact that like it was like carrying like a mini operating system, like but in a zip file. So Docker wasn't like the first tool that actually did this. There are like several instances of container runtimes. Docker actually isn't a container tool. It's more of a container runtime. I would explain what runtimes are in a bit, but generally Docker is the simplest one because of the Docker file. Most other ones, they're not too simple to get into, or they even use the Docker file to even run their own builds, if it makes sense. But that's why Docker is so popular, because they were the first company that oversimplified running applications in Linux containers. So generally, when you're running applications within containers, there are like a couple things that come to mind. The first one is that Docker doesn't run an operating system in itself. Docker runs on top of an operating system. You could think of it as an application to run applications, if you get. So generally, it means that an operating system running. The reasons for this are quite out of the scope of a simple talk, but generally, Docker uses the operating system to be able to manage multiple applications within containers. So such that if you wanted to use your camera within a Docker application, and you can actually do that. So Docker can run both graphical applications and command line applications, web servers, etc. But generally, people just use it for CLI, things like web servers and all that. But the main idea is that Docker cannot access your web camera directly because it doesn't have drivers. It doesn't do any of that. So your operating system now connects to Docker. Docker can now use it to get access to drivers, and then you can now use things like your cameras, your keyboard, and all that. That's how Docker works, and that's why to run a container, you need to first of all install Docker on top of an operating system. Think of it like an add-on, if it makes sense. So generally, the way containers started off is through things like Cgroups and namespaces. So Cgroups is basically called control groups, and what they mainly do is to manage the way you allocate resources to your containers. So to keep it simple, it's just like me running a web, like a browser, yeah? Like say something like Chrome that takes up like 2 gigs of memory just for starting up. Normally, I can't limit how much memory Chrome is going to use at a go, you get? And this was a thing back then for running applications, because if you ran an application and then say you got into like some weird loop and then it just started eating up memory on your server, like your entire server could lock down. You couldn't even have access to access the server because the SSH stuff that's supposed to manage you getting in can't run because there's no memory for it to run. So this kind of things cause a lot of problems. They're also malware because someone would install software that was compromised and all of a sudden the entire server is inaccessible, etc, etc. So what Cgroups basically did was that, okay, fine, let's manage how much resources in terms of like compute, like CPU, like RAM, all those kind of things, so that it would then be possible to run these applications in, you could call it like a sandbox where all the resources they need is pre-allocated and they can't take more than that. So that's how containers then started. And then it also then got to the part of Windows. So contrary to popular opinion, containers are not, it's a Linux thing. Linux namespaces and Linux Cgroups are actually what make up Linux containers. It's actually in the name, Linux containers. It's not Windows containers or etc, etc. The reason why Windows can run Docker is because they had to walk around several loops in trying to make the same functionality happen with Docker. So Windows doesn't actually run containers. Windows runs Docker. Docker now runs a VM to run your containers, and that VM, as you guess, is a Linux container. So hence the term here. So generally, Cgroups have a couple things in there. Like you can have Cgroups that inherit other Cgroups. So if I have a Cgroup that manages CPU, I have a Cgroup that manages memory, I have a Cgroup that manages, which CPUs the application can run on, then you can basically just add them together. And as you see here, everything that Cgroups do are like pretty much outlined here in summary. You can use it to like limit how much something can use, choose whether this application should always have priority. So if I'm running a web server and I'm running a database, I always want the database to be available. So I might say that, okay, fine, for this particular thing, this database running in this Linux container can have priority over that. And all of this is completely managed. You can specify it as Docker control flags, but pretty much all of that is there. Then this is just a short outline of how Cgroups work through Docker. So for those of us who might have used Docker, like these two at the end, those are our containers. But Docker now manages how much CPU those two applications can even use. So that's one of the beauty of Docker. It basically just simplifies how to manage those things independently. For the Cgroups part, we have a couple. We have things like memory, CPU sets. What CPU sets is for is that in some like high-scale enterprise applications, some CPUs are closer to certain parts of the board that make it easier to access memory. Like some CPUs are much closer to RAM. So the difference between running it on those CPUs and another CPU might be like a couple milliseconds, but then in terms of like the workload, you might be receiving like 1 million requests per second. So you guess like that saves a lot of time because you now have like 1,000 plus more requests that you can run. So sometimes it makes more sense to say that, okay, fine, these applications can only run within this particular set of CPUs. and then that's it. So that's where Cgroups come in. Docker also does this. You have things like netprio, which I've forgotten about that, but it's something dedicated to IO. Then block IO, which is for disk access. So how much, how fast can your application run within that C group? Things like that, so that in case something is within a file and then the file is very large, it doesn't just cause the entire system to freeze. It will have like a limit on how much it can use. So what I've just spoken about is just C groups and all those, and what they do basically for Docker in essence, like in the underlying core, is just manage what your application can see, well, rather what your application can use in terms of that. So you notice all of this where things like CPU, RAM, disk, and several other parts. Dev is relating to like files on your system. TLB is like a translook aside buffer, things for like caches and all that. But what namespaces do is what your application can see. So this is where Docker now comes into shine, because most times when you run an application on Docker, you tend to fall into the sense that because it's running on Docker, that basically means that your application cannot look outside the container. Yeah, like it cannot see anything outside where it's running. And that's the beauty of what Docker does. This is implemented by Linux namespaces, if it makes sense. So there are various Linux namespaces, and I'll go into them in a bit. But just to summarize, going back to like the entire web browser example, like take for example, if like Chrome was running on my system and then I wanted to open a file in Chrome. Normally, when you want to upload a file, you just click on that upload button and then you get access to like your entire system's folders. You get. Now, the issue with that is like when you begin to worry about security and things like that, it's quite worrisome to know that an application can just see everything you get. So if that application were like a database, then that means that they can see the data of all your other users aside themselves. And that's not really too good. So what Linux namespaces does is that, okay, fine, if you actually want to see into the database, you can only see the data you created, nothing more. And then there is no way you can look outside because you are basically namespaced to a particular region. You are isolated, you are restricted. That's like what namespaces do. They just restrict you to a particular set of things that namespace can provide you. And generally, those namespaces, these are actually types of namespaces, but those namespaces are generally things like PID, which is like processes. So if you're running in a container, and you start the process, it's only those processes that you created that you can see. Mount is things like that database example. Basically, if you need something from the other files from like another place that is not your own, you have to bring it into where you're running. Similar to like how you get a delivery, you can't have it remotely. You can't have it in another place. If you want it, you have to bring it into your own namespace so that at least you can use it there. Like how some of us might go to a pool, like somewhere to have fun. But if you're running in a namespace, you can't access that pool. So it's either you bring the pool to your house, or actually, that's the only way, typically. You can't get access. That was actually just a trick question. Network is for things like networking, for things like host names, and then etc. Users are for things like, okay, fine, like if I just want this user to run as its own user, not as the user that my system is running on, you get that you can also use that namespace like that. There are also things like volumes. So this is similar to what I was talking about with the mount namespace. So like if you actually want something to be able to see folders or something that is on your system that is outside the namespace, you have to mount it in. So it's pretty simple like that. So generally, there are like different drivers that do this, but all of this I can just leave it out for now. Are there like any questions so far? Just to get an idea. Okay then. I'll just move on to like what container runtimes are. So before, like when I started, you have heard me saying something like Docker really isn't like a container. It's more of like a container runtime. So basically, what container runtimes do is they basically run containers. Like that's all they do. So you would notice that like when I was explaining it, like I never made mention of Docker when I was saying C groups and namespaces, because C groups and namespaces are what make up Docker. Like literally. The only thing is just that Docker now has like some programmatic access to C groups and namespaces. So it's almost like rather than setting them up manually, Docker now just helps you automate it with that Docker file that I spoke about before that oversimplify the entire process. So generally, Docker container runtimes are just tools that help you set stuff up on Linux. And as I've said before, containers are a Linux thing. Like any operating system you see outside Linux that runs containers is emulating, like they are running a VM. If I'm using a Mac and running Docker, I'm basically running Docker. I'm basically running a Linux VM to run Docker, if it makes sense. So Docker is its own container runtime. It implements things. There are various other container runtimes. And generally, there's this post containers. The containers existed before Docker. Like back in the days of like raw sysadmin, where people would just like spin up VMs and push stuff into it, before the advent of things like Kubernetes, infrastructure as services, etc., etc. Like people would use C groups and namespaces to restrict their applications and all that, but it was quite tiresome and you had to know what you were doing. So it took quite a while of work. Docker offers simplifies that such that like anybody anywhere can just pick up a Docker file online, paste it in their system, run a build, and then that's it. So generally, when you think of Docker, always think of container runtimes. And when you think of container runtimes, just think of C groups and namespaces, because that's just all they are. So from here, you'll see a couple list of container runtimes. You can Google a couple. Like you see that they do exactly the same thing. Some might be deprecated. Like now, LXC was somewhat the first container runtime before Docker, but LXC was not as simple to use as Docker. It wasn't as extensible. It wasn't as, modular. You couldn't do stuff so easily with LXC and all that. But there are various others, container D, Runc, CRI, OpenVZ, and like many. And that's just pretty much Docker in general. There are like a couple links here. I'll possibly like send them out with the slides, so that at least for those who might be willing to get an idea of like how C groups, namespaces, and Docker fits together, and it becomes a lot easier. And likewise, on the second example, someone actually implemented his own version of Docker just with C groups and names and Docker repository. So as you notice, it's not something that can just be done with Docker. You could actually write your own if you want to. So, thank you.
Okay. Thank you very much for this session. Okay, please, if you have your questions, can you please write them down in the comment section? Any questions?
Okay, cool.
Okay, so there's a question from Abdullah. It says, what is the Docker Compose?
Oh, okay, yeah. So generally, Docker is Docker runs containers, yeah. But what about if you wanted to run multiple containers at the same time? From what I explained, like I was only using the instance where you're running only one container, yeah. But similar to like when you're on your system and you want to run multiple applications, like take for example, now if I wanted to run Google Chrome, but I also need to run say Windows Explorer before I can run Google Chrome. You get? So in a sense, Google Chrome is a dependency container. Sorry, Windows Explorer is a dependency container. Without Windows Explorer, you can't find the Google Chrome icon to click on, if you get. So what Docker Compose does is that, like, okay, fine. What about if there was now a way to now specify dependencies with containers, so that if I wanted to run Google Chrome, I would first of all need to start Windows Explorer. Then I can now merge Windows Explorer and Google Chrome in the same namespace so that they can now see each other. Does it make sense? Because with Docker, every application runs in its own namespace. But what Docker Compose does is that, okay, fine, now we can run multiple applications within the same namespace, if it makes sense. So it's like me being able to run all my applications on one computer, then I now want to be able to access those, like another set of applications on another computer, but they should be able to see each other. Okay, so someone has a question like, can you familiarize us with the Docker environments? Okay, like a practical. Okay, cool then. So let me actually then show that. I was actually of the hopes that it might be a bit too much, but so let me just like a very short example. So generally, the first sense to getting started with Docker is basically just to Google Docker. Docker is a very simple tool, but I would say Docker installation. Yes. You can then click on this and then install Docker for whichever version of the operating system you're running in. So let me actually just run Docker now, just real quick. So this is Docker. I'm running a Mac. So basically, like I have to start Docker the same way I start like most other applications. So in this case right now, Docker is starting. Is it? So in this case right now, Docker is starting. If I move to my terminal, I hope you can see my screen clearly, just to confirm again. Yeah?
Yeah.
Okay. So right now, if I open my terminal, and then, okay, something seems to be wrong with my, okay, it's fine. Okay, so what I'll do right now is I want to close this. Something seems to be wrong with my terminal. Yeah. Okay. So right now, what I'm just going to do right now is to that. So it seems my terminal is messing up. There we go. So right now, this is my terminal. Apologies, there seems to be quite some interruptions with this. Okay. Okay. It seems I'm having some issues accessing my terminal. I think that's fine. No, it's not. It's terminating for some reason. Actually, it is. Okay. So what I'll just do here right now is to just give like an easier example. So normally on Quick Lab, there's like a Docker intro that basically now just takes you into what you could use to get started with Docker. This is actually a pretty simple example, and you can basically access it. So what this will do is just take you through like a couple short examples on getting started with. So let me sign in so that at least I can walk through this from here. So generally, yeah, so generally like this.
Okay, since probably Bakare has he has internet issues. So
Oh no. Oh no. No, I'm back again. Yeah.
okay.
So yes. Okay, so let me switch. Okay, so let me actually now present. Just to like get back to the quick lab. Um okay, still tell me if you can see my screen. Okay. Yes, I guess you should be able to. Okay. So I'm just going to go to the quick lab on introduction to Docker. Okay. Yes. Okay, yes. Okay, I just saw another question, which is can Docker run containers concurrently without crashing ports? Okay, yeah, so this would depend on whether they're running in the same namespace or not. So if like say you've used Docker Compose and then you said that an application should be running on port 80, then you now run another application in the same namespace that's running on port 80, then those ports would crash because it's in the same environment. It's like running it on the same system. You get. But if they're in different namespaces, like you start a Docker container running port 80 on one side, you start a Docker container running port 80 on another side. Like if they're in different namespaces, then they won't crash. So you can run many instances of that and take go. There's also the case where you run it and then you expose the ports, then you then have, but then like when you expose a port, you're basically bringing it into the same namespace, which is your computer's namespace. So it's pretty much like that. So now I'm just going to run a start on this. I'll send a link to the meet now, so that at least others who might um see it can also try it out. Yes. So now, I'm just going to go through like a very short example on this. Yeah, I'm not a robot. Launch with 1 credit, and then yeah. So right now you see it's provisioning lab resources. So the platform I'm using here is called Quick Labs. What Quick Labs enables you to do is test out short but very simple practical labs on various things. It could be related to infrastructure. It could be related to programming. It could be related to a lot of things. But they have like a lot of labs that basically emphasize on getting people started with these kind of things. So if it's not too much time, one could always check this out, get started. In case that is a bit too much, like you can also run it locally in your system. Normally, there's a very, very simple Docker Hello World installation that walks you through getting started with Docker. Let me actually send this also. So if you ever feel like, okay, you want to actually get started in Docker, then these two resources would help. Um, I'm just looking at the time because quick labs can take a while before it's okay, so it's good. So now what I'm going to do here right now is I'm going to open this in a new incognito window. Then I'm just going to split my screen so that at least everyone can see that. I'm going to log in, then put in a password,
Aro!
and then from there I get access to Google Cloud. So in this case right now, what I'm going to do is I'm going to install
Close the
and
door.
run Docker on like a Google Cloud VM, if it makes sense. That's what this is going to be about. So right now I followed on the instructions where I've signed in. Now what I'm going to do next is to continue with this next lab, which is so as you see, which is here. So what they said I should do is that I should open up a Cloud Console shell, as you see here, activate Cloud Shell. And the cloud shell is always at this top right corner of the screen. Once you click on it, you see a very short bar here that tells you that you know you can run whatever process you want in here. Um, so it's starting up. What I'm just going to do is I'm just going to do all of this, then I'm just going to run Docker hello world. So moving forward, I'm just going to check whether everything is correct. I'll do an alt list, which is just going to, tell me whether I'm authenticated properly here. And as you see, this is active. This is my account. To use Docker, in this case, what I'm just going to do is I'm going to do Docker run hello world. And for those who might have noticed, it's basically the same part that you would run here. Like once you've gotten past the setup and then you get to the part where you want to run the container, then you get to this point where you might run a build and all that. But in this case right now, I'm just going to run the hello world application. For those who might want to, you could then move forward to copying this Docker file, pasting it in, running the commands that are listed here, and then to just work fine. But here I'm following the Google Cloud Quick Labs tests, and then the first command I'm meant to run is Docker run hello world. So what this is just going to do is that it's just going to download the Docker application, and then it's just going to show me whether I have it or not. In this case, I didn't have the image. So the image is like a zip file that contains everything that you need. So when you are running with Docker, because I just covered the internals, but in general, when you're running with Docker, you would have images, and then those images would run. So in this case right now, you can see what this guy posted was like, hello from Docker. This shows that your installation is successful. So pretty much this is how Docker works. You notice that I didn't do anything. I didn't install any applications. I just downloaded an image and then I ran it and it just worked. So that's pretty much like how Docker works. If you want to get a list of all the images that you have, you do something like Docker images. What this will show you is just like, okay, fine. Within this part, I have an hello world image. If I were to say I want to run something else that is not hello world, say I wanted to run something like Apache. For those of Apache is like a web server, you see that it's going to try to download Apache. Apache does not really exist. Let me try something and it's a lot better. Like say like something like Node.js. Then it's going to say you can't pull from Node.js. There are like a couple things, but to get the images, you would go to Docker Hub and then just check for like hub.docker.com, and then from there you just check for something like Node.js or Apache. And you get like the image, and then you can just copy this and run it in here. Like you will see the command once you even open it, httpd. So I can come here and do Docker run httpd, and then now you notice that it's pulling the image for httpd and it starts in it. So you get, so on a normal day to do this, I would have had to install httpd, then I'll now run httpd. But you notice that with Docker, I just needed to find the image that has httpd and run it. And now it's running in its own namespace. I could choose to open another terminal. For the person who said that, will I have crashing ports? Yeah, you'll see that this will be running on port 80. And you can check that with something like Docker PS. It will just show you all the ports that are running. And here you see that this is running in port 80. If I were to do Docker run HTTPD again, then if they are running on the same port, then this should, stop working. But you notice that it's still running fine.
Money I give.
And if I come here again,
300 naira.
Right now is I have two of the same applications running on what? Port 80. And the reason why this happens is because they're running in different namespaces. So it's like they're running on different systems. They can't see each other. They don't know each other exists. And that's pretty much the simplicity of Docker, generally. So here you could try other things like Docker PS. I've already done this. You could try doing a build, although I'll leave this for others who might be more interested in getting started in Docker. And as you continue, you'd basically see that Docker really simplifies a lot of the things you try to do when you're running your applications. Yeah. Um, are there like any more questions? Perhaps.
Oluwa. Okay, so
Okay, hello.
okay.
Oh yeah.
In the
Hello. Hello, boss.
absence of any questions,
What
I think we'll just
like what's the beauty of using Docker? Like, what's the use of using Docker actually?
Okay. Okay, cool. So if you notice here, like when I was
Oluwa
running HTTPD, let me share my screen again.
can
Yeah.
kill somebody.
Like I want to show you something very different. So the beauty of using Docker is that like compared to like when I was running um this, you notice that I could run two applications. Like you didn't see me do anything like apt install HTTPD, right?
Who
You
is
didn't see me
that?
do any of this because because of the fact that everything I need to run the application is already in an image. I don't need to install it again. I can just reuse it. So similar to like how it is like when you have an operating system. Yeah. Like if your Windows gets bad, you have to basically reinstall your Windows. Yeah. You have to format it, put a new one on it. You get the beauty of Docker is that like if that part gets bad, I can literally just reuse the same image I had when I started running it and just use it again, if you get. And all the data I had inside, all of that, if they're like in a volume, it will basically be like the operating system
What
was
happened?
always fine. But if you notice the parts that I said before, like if you basically formatted everything before because you were running it on the VM, like you have to start over from scratch.
Instead of you to wear clothes, you are
But
still
if you notice
pressing
here right
phone.
now, right, if I try to run HTTPD, you
Wear
notice
your
that
clothes
I'm
and
basically just doing the same thing again. And then I'll go to a new tab and then I'll see that, oh, I've just been able to run another instance of HTTPD without doing anything else. So Docker is like reusable, consider it like a reusable environment. You get like I don't need to like once I've done it the first time, I can just keep doing it multiple times and nothing bad will happen. If it makes sense. Like it's like running an application on your system. Once you've run like take for example, if you run Google Chrome, you can't run Google like and you run Google Chrome again. You can't run Google Chrome again because it's just one application. You get in this case right now, it's like me running three Google Chromes on the same system. You get and all of them have different identities, like they're different from each other. Okay, I'm trying to see how to really simplify this.
Okay,
Um,
yeah, I get what you mean. It's just like basically you call it like an image is just like, let me just put it this way, like it's
okay.
just maybe the CD, those CD plates you buy from, maybe let me say,
Exactly,
and
exactly. So,
then you can install
yes,
it on many laptops. Yeah,
different
I get
system. Yeah,
exactly.
exactly that.
Yeah, thank you.
So that's what Docker really helps you with. Like, I can take that same CD, install it on this system, install it on that system, but the main CD itself never changes. So the CD is basically like the image, and then Docker is basically the what you use to now run the application on the CD. Um, so Okay, so and the last said that I should come again. So you could think of the image that Docker runs as the CD. The image is always going to run the same, irrespective of wherever you run it. You get as far as that CD has a CD drive, which is Docker, if you get. So if that
please let me
system
close this door
has a
now.
CD drive that is representative of
Elijah,
Docker,
have you eaten?
then Docker can run that image for you. And
Close
then
this
you
door. I
can
want to
put in
try
that
something.
CD
Nobody
in,
should
run
talk,
it, you can
please.
remove it, run it again, remove it, run it again, and it will always work the
I
same way
didn't hear you.
if you get.
I want to try
So
something.
Eniola, I hope that like simplifies it. I'm not certain if that makes sense. If you were running without Docker, then you can't really reuse the same CD. Once you've used it on one system, you can't
Let me
reuse it on
close.
the other system easily. You have to remove the hard drive and plug it into another system, and that's like how VMs used to run. You couldn't really share it. You had to reinstall it every single time, if it makes sense.
Close door, close door.
Does it make
Thanks.
sense? Okay.
I'm trying to I'm still trying
Okay.
to understand.
Okay. Um. Okay. Okay. Let me actually break it down in this manner. Um. You would actually just think of Docker as, so let me use Google Chrome as an example. Yeah.
What?
Like in Google
Okay.
Chrome, you can run multiple tabs. Yeah. Yeah. I can
Yes.
open up I can open up the same tab in multiple tabs. Yeah. And all those tabs will basically be independent. Yeah. They are running as though the other tabs don't exist. Yeah. If I do something on this, the other tab is not going to know that I did something there. Does that make sense? You
Yes.
get. So if Google Chrome was a Docker environment, basically, the image is the URL, and then the tab is basically, what do you call it? You could think of URL as the image, and then you can now think of the tab as the container. So Google Chrome being Docker can run many images which are tabs, but those tabs don't see each other. They can't affect each other. You get. If I scroll up, like now, take for example, if I duplicate this tab and I basically use this same image to create another tab. Yeah. If I come here and I scroll down, you get, and I come here, you see that this guy is still the same. It's basically where it says this tab cannot affect this tab. So it's like they're running in different what? Namespaces. Does it make sense? And then because those tabs are now like images, I could run as many of them as I want, if you get. And they would always work the same. You get. If I open this tab in another, if I open this one in another tab, it's still going to be exactly the same thing I'll get back. The only thing is just that you notice that it basically starts again. It's almost like it's a new fresh instance. You get. Like now here, this one is showing end lab, but here you notice that it's not. You get. So if I make a change in this tab, it won't affect this tab. So that's like how Docker images and everything works. Does it make sense?
Yes, it does. Definitely not.
Yeah. So that's like the simplest explanation of Docker. Provided you have Docker installed, you can run as many instances of it and nothing bad will happen. You get, they are completely isolated. Okay, yes. So to take Somto Triku's question, how does Docker compare to Kubernetes? So in general, Kubernetes uses Docker. To keep it simple, Kubernetes just allows you um, run Docker across multiple systems. If you get, because if you notice this guy, Docker is only running on one system. What Kubernetes is that, okay, fine. Instead of running Docker on a single system, you now run Docker in a cluster. But you can Google it. It's basically like me owning multiple houses and then putting people in the houses. You get, like, if I were Kubernetes and the houses were Docker, then I can basically run containers in multiple houses. If you get, and me as the people and me as the person, I'm an image. So I'm basically the landowner. I'm Kubernetes. Then I have multiple houses that are Docker. But in those houses you have rooms, and those rooms can be containers. If you get, because the rooms are independent of who lives in them. If you get, then you as the person that lives in there, you're not like the image. So I could put multiple images in multiple Docker instances that are the houses, and it just work fine. So Kubernetes uses Docker to run images, but on multiple systems, if it makes sense. Like a cluster of Dockers. You could think of Kubernetes like that. A cluster of Dockers. Yeah. So, like, I think I could. Okay, let me actually draw that out so that at least it makes sense. Yeah, pretty much, like, so that at least others who might be thinking of. So you could think of it like this. Uh, so like if this were Kubernetes, yeah, if this were Kubernetes, then I could run Docker in here, I could run Docker in here. I could run Docker in here. I could run Docker in here. Then inside all these Docker stuffs, I could now have image one. You get, I'll now have an image in here. I'll have an image in here, if it makes sense. So I'll just have, so it's just like Docker, 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 then an image. But then I can see everything in one place because of what Kubernetes, if it makes sense. So it's like higher level Docker, if you get. Yeah. No, actually, Docker is not the only one. So from my previous slides, I was talking about container runtimes. So if you just Google container runtimes, you come across a couple of them. Like you see that Kubernetes has something on container runtimes because Kubernetes uses. It's not like it uses container runtimes, but pretty much is Docker. You get. So you see Cgroup drivers here. Remember I explained Cgroups. You see Docker here. You see another container runtime, CRIO. For those who saw the slides, I mentioned CRIO. You see CRIO. You see container D, which is another container runtime. etc. You get. So Docker is not a containerization software. Docker is a container runtime. And what container runtimes do is they run containers. It's that simple. Why would you need Kubernetes? Okay. Just to keep it very, very simple. If I run Docker on my computer crashes, then pretty much that makes sense. If I run Docker on multiple systems, I can risk one system going down, but another system will still have all my applications. If you get, that's why you need Kubernetes for availability. If it's basically like I'm going to say this quite rashly, not to cause any offense, but it's basically like a woman having multiple children or a family having multiple people. If one person goes, the other, like you have more people to continue the family. So pretty much, if that makes sense. So yeah, so that's why you need Kubernetes. If Docker alone will only run on one computer, Kubernetes will run across multiple computers. One computer goes down, you can run it on the next one. Yeah. Okay. So I hope I've been able to answer everything correctly. I hope it was simple enough. I really tried to make sure I was straightforward as possible. If it's fine, I guess, yeah, I'll be ending the talk now. If Fihan, is there anything else?
Okay, thank you very much, Bakari, for the talk. So up next, we'll be having another person taking us
Thank you.
through an introduction to Google Cloud. So Abba Jibril, over to you. Abba Jibril is the lead for Bayero Kano, the DSC we have the collaboration with. So over to you, Abba Jibril.
So, good morning, everyone. As Ifihan said, my name is Abba Jibril, and I'm the DSC lead for Bayero University, Kano. Do confirm if you can hear me, please.
Yeah, I can.
All right. Let me have my slides, please, Ifihan. So sorry about the topic. Go to next slide, if you. So I'll be discussing what cloud is in general, what Google Cloud is, and how we can use it. At number 3, we will be running demos of Google Cloud Compute, Google Cloud Storage, and then finally Cloud Functions. So let's get started. Next slide. So what is cloud? Had in people's mouth everywhere. People are talking about cloud everywhere. So what is cloud? So to understand cloud better, we need to look at how we got here in the first place. So the first wave that brought us towards cloud computing was co-location, which IT shops have been doing for decades. Co-location is taking your existing IT infrastructure and rehousing it in a data center, basically. Instead of building costly capital-intensive data centers, IT shops can just rent space in shared facilities and move their infrastructure there. So the data centers provide them with power, network connectivity, and also cooling. That frees up capital for more flexible uses. Until recent developments with co-location, the user is expected to configure, manage, and maintain their infrastructure. Then we got to virtualization. At this point, IT departments needed more efficiency, so that drove them to use virtualization. The components of a virtualized data center matched that of a physical data center. It also has servers, disks, and so on. But now they are virtualized devices separately manageable from the underlying hardware. Virtualization lets us all use resources more efficiently, and just like co-location, it lets us be more flexible too. With virtualization, you still have to buy, house, and maintain the infrastructure. So you're still in the business of guessing how much hardware you will need and when, setting it up and keeping it running. At this point, companies like Google realized that its business couldn't move fast enough within the confines of the virtualization model. So Google switched to a container-based architecture, as Emmanuel explained containers earlier. Google switched to a container-based architecture and automated elastic third web cloud builds from automated services. In Google's internal clouds, services automatically provision and configure the infrastructure that is on which Google used to run familiar Google applications. Google spent billions of dollars in building this platform and making it resilient and efficient. And today, Google Cloud Platform, GCP, makes it available to customers and almost everyone interested. Next slide, please. So the cloud today, when people talk about the cloud today, they sound like the cloud is a whole one thing, but the cloud actually comprises of a lot of different technologies, a lot of different architectures, and a lot of ways to accomplish tasks and build solutions. So when we talk about infrastructure as a service, we're talking about moving your infrastructure to the cloud. But then what exactly is infrastructure? So your racks, your servers, processors, and so much more are what are referred to as infrastructures. So with infrastructure as a service, you no longer have to buy this. They can be hosted somewhere else, managed and maintained by the cloud service providers like Google Cloud Platform, AWS, Microsoft Azure, and the rest.
Elijah.
And you don't even have to spend as much as you spend when you're buying physical infrastructure. Best part of it all is that these infrastructures are scalable. You can basically request for storage upgrade without affecting what you already have on the infrastructure. Instead of like when you have a server and then the storage doesn't meet your needs anymore, you have to go and get another server. In this case, you don't have to do that. All you have to do is request for more storage, and then you get it on an instant. When you don't need the storage you have already, you can also down in such a way that you only pay for what you use. And all you have to do is just to run the infrastructure for the time you need it. Then platform as a service. Basically, when you hear platform as a service, we're almost always talking about some sort of web-based application. Now, the simplest platform as a service is a good old-fashioned shared hosting plans from one of the web services providers like GoDaddy, One and One, and the rest. You don't worry about the php.ini file. You don't worry about the RAM, the processor, or the updates to the server. You basically don't worry about all this. All you worry about is the folder you get to dump all your code into, and then that code uses the services provided to run. So platform as a service is not so much common because it is mostly used by developers, or should I say professionals rather. So the last one on the list, software as a service. This is by far the most commonly used cloud service. You probably use it every day regardless of your level of expertise or IT use. So SaaS allows users to instantly connect and use cloud-based applications over the internet. Instead of having a software installed on your computer, it is hosted by someone else in maybe a different country or rather a different continent, no matter the location. So the cloud service provider manages all the aspects of the application. We, the consumers, just have to focus on using the application. A huge use case is email clients. So Gmail, for instance, we're connected to Google Mail through browser. The entire application is hosted on Google, is hosted by Google rather. In this case, our cloud provider. All we're going to do is focus on using it. We don't develop it, we don't host it, we don't manage it, we just use it. Another example is Microsoft Office 365. And there are a lot of more software as a service platforms out there. So next slide, please. So now, what is cloud? What is cloud from your own understanding? So as you can see here, next slide, please. To a layman understanding, cloud is a visible mass of condensed water vapor floating in the atmosphere, typically high above the general level of the ground. But then, next slide. Cloud is basically a collection of tools and resources to help developers spend less time managing details and more time creating. That's basically cloud. Next slide. So what is Google Cloud? So all the services we access on Google Cloud Platform, including what we just discussed, platform as a service, infrastructure, software as a service, are all part of Google Clouds. You can see Firebase is a platform as a service, Google Maps, software as a service, the G Suite, and the rest. They're all part of Google Cloud, and the platform to access them is Google Cloud Platform. Next slide. So we're gonna take some little demos. Let me share my screen. All right. Ifyan, can you stop presenting? Okay. Just a minute. All right, so here we go. So the first item on our demo agenda is Google Cloud compute rather. So there are basically a lot of resources on the compute tab, but then we're going to look at virtual machines, VM. So from your navigation bar, from your project dashboard, this is the dashboard you're seeing. Click on the navigation bar. On the top of the list, you can see VM instances. Click on it. Wait while it loads. And then click on create. You can read the description there for more information. So here you list of items. And then here you just have to insert a name for your instance, for your virtual machine instance. It could be anything. Then here you have region where you want that instance to be saved. And then here you have the machine configuration where you choose the amount of memory you want, the processing power and everything. And then here, that is the operating system. Here we have Debian, Linux 10. You can decide to change it. GCP has a lot of that. You can change it here. You have Debian Linux 9. You can decide to change the OS entirely. You have Windows Server and the rest. So we're going to stick to the one we have as default. So then I think that's all. You should leave the rest as they are unless you're required to change them. Then you should allow HTTP traffic and then hit on create. So you just wait until it is set up. So until you see a green dot right here, it means, okay, we have it now. So it simply means our VM instance is running right now. And this is the IP of the instance. So we should move to the next item, which is Google Cloud Storage. So again, from the navigation bar, you just scroll down to storage, click on browser. Wait for it to load. And then I already have some here, but then you can create a bucket. A bucket contains the image, that is what you're trying to store. So you have some sort of kind of roadmap, something. So you're to give a globally unique name to your bucket. That is a name that is unique, just like a username. No one else should have the name. So let's see. So continue. Choose where to store your data. That is the region. Google has lots of data centers all over the world, so you have to choose where you want to. So we're going to leave this as default and then continue. Choose a default storage class for your data. We're going to leave it on standard. You can read the details later. Choose how to control access to objects. We're also going to leave it as default. Then continue. So advanced settings, we're also going to leave it as default. So create. So our bucket has been created. And as you can see, the bucket details, the name is as we specified. And then here you can see a list of all the items in the bucket. So right now we have no item. So we can upload files, upload folders, create folders. So let's try uploading a file. Let's upload this one. And it's uploaded. On the list now. But then you can't access it publicly because we haven't created any public access link. You can see it here, no public. So to do this, you click on this navigation, edit permissions. Then add an entry, entity, public, name all users. Then you leave this one as reader because if you add owner, anyone can edit it. So you save. And there you go. We have a public URL. To access this, let me show you. So when we paste the URL, we get our image. So with this link, you can use it anywhere over the internet. It's public. So I think that's all for cloud storage. And then now for cloud functions. So from the navigation bar, you scroll down to cloud functions, click on it, and then you create one. Yeah, so you select the region, trigger, we'll go with HTTP, and then save, move on, next. So we actually need to enable an API for us to be able to run the cloud function. Sorry, I actually forgot to enable it before starting. So let's enable it. Just a minute. Okay, there we go. I think it's enabled. So let's go back to our cloud function. Create one. Leave the region as default, trigger HTTP, and click on next. So here we go. So you can choose any runtime you want. There are a lot of runtimes here, but we're going to stick to the default, Node.js 10. And then entry point is hello world. We don't need to change anything right here. And then we deploy it. So I think in a matter of seconds, our function would be up and running. Okay, I think my internet is a bit slow.
Okay, it seems about Jibril has little internet issues. We just wait for him to get back on the call. Thank you. I'm going to, Okay, since he hasn't still joined yet, so for the meantime, before he joins back, please, if you have any questions, you can start placing them in the comment section so that when he comes back, be able to um, be able to read out the questions for him.
Hi, can you all hear me now?
Oh yeah, he's back. Yeah, yes.
So I can see some questions here. Is there an upper limit to the number of cloud functions that can be triggered simultaneously? So sure, depending on the depending on the region and then the platform on which you're running the cloud functions. For instance, it's just like you having multiple PCs and then running a single applications on all of them. So you can basically do it. You have no limits. But then if you're running the function on a single VM, I think there is a limit, but I'm not sure about the specific limit. I don't know. Am I clear with your question? So you're running it on the cloud, on server somewhere, right? So basically, it's like you having multiple servers right in front of you and running a single application on all of them. So it really doesn't affect, one doesn't affect the other. So you can basically run multiple, you can trigger multiple functions at the same time. Are we clear?
Any more
Sure, I think
questions?
you would have a limit on that. You sure hit a limit, but I don't know the specific limit. Oh well, sure. Like Google Cloud functions are also serverless. Also serverless ways of running event-driven applications. Any more questions?
Okay.
Okay, I think that's all.
No, there's one more question. Does Google Cloud have serverless cloud?
Yeah, I think I answered that. I said
Okay.
yes. Google function itself is a serverless is a serverless cloud
Okay.
function for running event-driven applications.
Okay. So, in the absence of any other question, okay, which one was Emmanuel in this question? I think he has answered that. Um, about Jibril, I think you've answered what Google functions are specifically for, right?
Yeah, basically they're for running event-driven, lightweight event-driven applications. I think I've answered that.
Okay. So, Emmanuel, I think he has answered your question already. So, in the absence of no more questions, yeah, our last speaker isn't going. We'll not be having our last speaker for this session. He, due to some reasons, he is unavailable. So, in the absence of any other questions, we'll be bringing this event to an end. And yeah, there should be a recorded version of this call, hopefully by tomorrow or today. So when it's available, I'll share the link to my chapter, and I'll send the link to Abba Jibril for him to also share out to his chapter. So thank you all for joining. Thank you for sparing your time for this event. There'll be other more cloud sessions. There'll be other cloud sessions as time goes on, and we'll also post it up when it's time. Thank you very much, and have a lovely weekend.
Thank you, everyone.